Assalamualaikum. My name is Mohd Fakhrullah bin Azizan. Sorry if I use these sunglasses because I have a little bit problem about my eyes. So now I will talk about introduction. So our aim of the project is to apply our knowledge on structural mechanics and to solve problem by designing the model of the bridge, which is the rail bridge. Modeling and simulation of the bridge are carried out using step pro, which is it output the forces, which is internal and external, and the deflection of the structure. All of that can be analyzed from that application of software. So the model bridge is designed as simply supported at the base. The contact base area at the end of the bridge is 2 meter times with 2 meter with 10 meter overall length, 3 meter height, 2 meter width, and 8 meter clear span between edges of supporting abutment. And then a uniform distributed load is clear, assigned for overall length of the bridge. All member of bridge designed using I-beam universal column, which is 305 times 305 times 283 millimeter. Alright, that's all from me. Thank you.
My name is Nabila, binti Mohd Rashdan, matrix number AA192090, and I will present about bridge design. So this is our bridge model design in 3D. As you can see, we use I-beam universal columns in 305 times 305 times 283 millimeter for all the members of the bridge, with 3 meter height, 2 meter width, and 8 meter clear span between edges of supporting abutment. This is the deflection that we obtain at the center of our bridge. So as you can see, for example, in distance 0.14, there is 0.0082 deflection in negative y direction. Also, for example, 1.67 meter from the center of the bridge, there is 0.1066 negative y deflection, which means this table is showing that this bridge is in minimal sagging. Next, the external force of the bridge. As you can see, there is no external force reacting on X direction and Z direction at the supports of the bridge. Meanwhile, in Y direction, both of the supports, pin and roller, consist of 65.367 kN acting upwards at the supports. Internal force in bridge. As you can see, this diagram showing us that the internal force is acting uniformly at the clear span between edges of the support bridge. Bridge elevation. Front view. This front view shows the full design of bridge with 2 times 2 times 10 meter contact base at the end of the bridge. This is the top view of the bridge. And for the side view, clearly this railway bridge is designed to allow the train to pass through this bridge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shukor Hakimi, matric number AA191011, and I will present for the manual calculation. For the manual calculation, as said from lecturer Dr. Aiman Bin Jamian, we have changed the loads from uniform load to nodal load. So for the calculation in reaction at support G, we have found that reaction at y-axis is Gy equal to 49.1 kN. For support reaction at A on y-axis, we have found that Ay equal to 48.95 kN. For both of the support reaction at AG on x-axis is equal to 0. For the calculation to find the internal force and the compression and tension, we have used the inspection method. So from the inspection method, we use to calculate the internal force and the compression and tension. So the compression and tension are shown in the slide. That's all from me. Thank you.
Hello, my name is Aiman Bin Jamian. Today I want to talk about the recommendation. Firstly, we need to have the innovative material to building bridge. The materials such as fiber, transformable polymer, corrosion resistant steel rebar, and high performance steel. This material is due to make sure that the bridge become lighter and could maintain their endurance towards stress, strong wind, and sun. Secondly, we should add more support to the bridge. We need to make sure that the bridge is strong enough to balance the load from vehicle at maximum point. To do this, engineer must have to calculate correctly the total support for that bridge to avoid bridge collapse. Third, every bridge should have walkway, motorcycle, and car line. This is important to avoid any accident between vehicle and people. As we know, many deaths in Malaysia are due to driver while driving. So, engineer must take this topic seriously and do the right. Lastly, we need to make a barrier on the bridge pole. It will help to avoid any item that could damage the post like leafing wood. Thank you.